The answer is lying, or the phi is lying in the third quadrant, and with the angle pi by 6, that is pi plus pi by 6. So the value of phi will be 7 pi by 6. So this is how the coordinates x, y, z, which is right now minus root 3, minus 1, 2 root 3, are now converted to spherical form 4 pi by 6, 7 pi by 6, right? And now using the same kind of relationship with Cartesian and cylindrical, we are converting now the same coordinates into Cartesian form. So for that, let us consider Cartesian and cylindrical coordinates. So, which are x is equals to r cos theta, y is equals to r sin theta, and z is equals to z. So, one of the coordinate is obtained very much straightforward, like this is z only, which is very much confirmed, 2 root 3. Now, after finding that, we'll go with immediately r, which is x square plus y square, which is nothing but 3 plus 1, 2. So as we have the value of r, we can go with the values of theta using x and y. That is cos theta is equals to x upon r, sin theta is equals to y upon r. So where x is minus root 3 by 2 and sin theta as minus 1 upon 2. As again we have the same third quadrant, the value of theta becomes nothing but 7 pi by 6. So here also the cylindrical coordinates r, theta and z are 2, 7 pi by 6, and z is 2 root 3 itself. So this is how the conversion of the coordinates are being made. Now, it is not necessary that every time Cartesian coordinates will be given to you. You may be given spherical coordinates, and then the question will be there, you have to convert it into Cartesian form. Or there may be the question only that if spherical coordinates are given, find out their cylindrical coordinates. In any of the case, first of all, you have to convert the spherical coordinates or cylindrical coordinates into Cartesian first, and then after only you can find out the cylindrical coordinate or spherical coordinates. So let us take one example of that type, in which now Cartesian is not given but spherical or cylindrical coordinates are given to you. So let us consider one example. If the spherical coordinates are 2, comma pi by 4, comma pi by 6. That means you are having the value of r, theta and phi, where r is equals to 2, theta is pi by 4, and phi is pi by 6. So let us start with the conversion of these spherical coordinates in it is in Cartesian form. So let's begin with Cartesian form first. Yeah, x equals to r sin theta cos phi. So we have all these values. R means 2, sin theta means pi by 4, cos phi means pi by 6. So by simplifying this, you will get 2, 1 upon root 2, and cos pi by 6, that is root 3 by 2. So you will be getting x is equals to root of 3 by 2. Same way we can go with y. Y is equals to 2 sin pi by 4 into sine pi by 6. 2, 1 upon root 2 and 1 upon 2. So you will be getting the answer as 1 upon root 2 only. And z can be obtained as r cos theta. R cos theta, that is 2 cos pi by 4. So answer will be 2 up into 1 upon root 2. Answer is root 2. So this is how we obtained the Cartesian coordinates as x, y, z equals to x we obtained as root of 3 by 2, y as 1 upon root 2 and z as root 2 only. Now using this converted Cartesian coordinates, we will find out the cylindrical coordinates. So for the cylindrical coordinates, using the same one, we have x is equals to r cos theta, y is equals to r sin theta, and z is equals to z, where r can be found as using x square plus y square. So what is x square in that case? It is 3 by 2 plus 1 by 2. Your answer will become root 2. So r is obtained. Now using r we can find out the theta values like this. X is equals to r cos theta. Therefore cos theta becomes x upon r. X upon r means root 3 upon root 2 into root 2. This becomes root 3 by 2. And the y value r sin theta, so that sin theta will become y upon r, y which was obtained as 1 upon root 2 upon root 2, that is 1 upon 2. So as sin theta is 1 upon 2, cos theta is root 3 by 2, both the values are positive. We have the very first quadrant for the theta value as pi by 6. Therefore the cylindrical coordinates r, theta and z are root 2, pi by 6 and z is root 2 again. So this is how the cylindrical coordinates can be obtained. And the same relationships are used to conversions of the equations also. Now using the same concept, we will see some examples based on the conversion of the equations. So for that, now let us try to convert the equations in spherical and cylindrical form. Let us consider the Cartesian equation 5x square plus 5y square is equals to 8 of z square. Let us start with the conversion of the equation into spherical form. So according to the spherical form, we will put in place of x r sin theta cos phi plus phi. In place of phi we will put r sin theta sin phi, both are in square terms, and in place of z we will put r cos theta only. So simplification will be as follows. 5 can be taken common, r square sin square theta cos square phi plus r square sin square theta sine square phi is equals to 8 r square cos square theta. So further you can take r square sine square theta common. You will be having 5 r square sine square theta into cos square phi plus sine square phi equals to 8 r square cos square theta. R square will be cancelled. A very basic identity, cos square theta plus sine square theta is 1. We have 5 sine square theta is equals to 8 cos square theta. So final answer will be tan square theta is equals to 8 upon 5, or 5 tan square theta is equals to 8. So this is what the required equation in spherical form. Right? Now using the same things, we will now convert this Cartesian equation, the same Cartesian equation, into cylindrical form. So considering the same equation, 5x square plus 5y square is equals to 8z square. We will try to convert it into cylindrical form now. So according to the cylindrical coordinate, x, in place of that we will replace it by cos r theta plus 5 r sin theta the whole square, and z won't be replaced, will remain as it is. 5 r square cos square theta plus 5 r square sin square theta is equals to 8z square. We have 5r square as common. In the bracket again a very usual identity we have, that is cos square theta plus sin square theta. So your answer will become 5r square is equals to 8z square, and in place of r square, according to the relation, you can put up x square plus y square. So your final answer is 5x square plus 5y square is equals to 8z square. So this is how the Cartesian equation is converted into the spherical and cylindrical form. As we have seen that any spherical coordinate can be converted into Cartesian form and then into cylindrical form, the same application is done for the equations also. That means if you have the spherical equation or Cartesian equation, you can convert it into Cartesian or cylindrical form. So let us take the same example for the idea. So this time we consider one spherical equation, a very well known equation, very important equation as well. If you have the spherical equation theta equals to pi by 6. Now we want to convert this equation theta is equals to pi by 6 into Cartesian form and cylindrical form as well. Let us begin with the Cartesian format first. Say x is equals to r sin theta sin phi, y is equals to r sin theta cos phi, and z is equals to r cos theta. And as we have the answer of theta, we can go with first z itself. So z is equals to r cos pi by 6. So that answer will give you r into root 3 upon 6. So you get the answer of r in terms of z. Sorry, that is 3 by 2. That is 2z upon root 3. And now we have very well known identity for Cartesian to spherical coordinates is r is nothing but under root of x square plus y square plus z square, so that x square plus y square plus z square, if you taking square both sides, we will get r square. X square plus y square plus z square, in place of r we will put this 2z upon root 3 whole square becomes 4z square upon 3. So final conclusion is and as per the simplification your answer is 3x square plus 3y square is equals to z square. This is what the converted equation in terms of Cartesian form. And now we'll go with the last point, that is conversion of the same equation theta equals to pi by 2 in cylindrical form. As theta is equals to pi by 6, we have a very well known relation, x is equals to r cos theta, y is equals to r sin theta, and z is equals to z. And now we have r square is equals to under root of x square plus y square, where theta is equals to pi by 6. So x upon r will be root 3 by 2. So x is equals to root 3 by 2 into r, and y is equals to 1 upon 2 into r. Using the same things and applying the values in it, we can obtain the cylindrical equation also. So I hope you got the proper work of. For any kind of queries, you can contact me on my number given, or you can send me the mail in the given. I'll be available as soon as possible. I'll try to reply you. Thank you very much.
SANDHAN, All Gujarat Integrated Classroom.